The motherboard brings together the various hardware devices in the PC, creating communication between the processor, memory, mass storage devices, and peripherals. The power supply that runs the computer and all hardware devices are connected to the system board directly or through the control card that runs it. The connecting unit of the motherboard is the bus system, bus, which consists of four main parts: address bus, data bus, control lines, and power lines. The address bus and the data bus consist of a certain number of wires, which specifies its bit width, i.e. the number of lines that carry the addresses or data. Through the address bus, the processor, CPU, accesses, addresses, memory and hardware devices. Its bit width determines the size of the memory size available at one time. The address bus is one-way, the processor always addresses the hardware devices. The data bus is a two-way bus, and the processor and all hardware devices send and receive data through it. Its bit width shows the size of the data that can be transferred. The control bus is not a unified bus like the address bus or the data bus. Its function is to implement control between hardware devices. It consists of input and output wires. The processor controls the hardware devices on the output lines and receives external requests on the input lines. Power lines provide the necessary power to the hardware devices. There are different types of buses based on different bus systems, local expansion buses, which determine the devices that can be connected to them. They are characterized by the bit width of the address bus and the data bus, as well as the data transfer rate, i.e. how much data, bits, it carries per second, and their other characteristics. The first bus system is the 8-bit data bus, the 20-bit address bus XT bus. Later, at bus or ISA, industry standard architecture, with a frequency of 8 MHz and a data transfer rate of 6 Mbps with the 16-bit data bus, the 24-bit address bus, the traditional 8-bit and new 16-bit slots, rail sockets, retained for compatibility. IBM PS2 motherboards have a 32-bit micro-channel bus. Not compatible with that bus. Mouse and keyboard connectors are still used in ATX motherboards. An enhanced version of the AT bus is the 32-bit data and address bus, 8 MHz clock, 33 Mbps data rate ISA, extended ISA. The first local bus is the 32-bit and 64-bit VLB, VISA local bus, with a clock speed of 33 MHz and a data rate of 120 Mbps. The latest is the PCI, Peripheral Component Interconnect Local Bus, which operates at 33 MHz clock speed on 326 motherboards at 32 bits with 133 Mbps, Pentium and later motherboards at 64 bits at 266 Mbps. Increasingly, the 8-bit SCSI, Small Computer System Interface, bus, adopted as an ANSI standard in 1986, handles a total of 7 devices, actually 8, but one address is reserved by the card itself. It is connected to ISA, ISA, and PCI buses as a control card. Transfer rate is 10 Mbps. An improved version of this is the 1632-bit SCSI 2 buses, which have existed since 1990 and have a data transfer rate of up to 40 Mbps. The SCSI 3 standard, which can handle up to 15 devices, has 16 addresses, has already been developed. Since all devices are connected to the same bus system, the assignment of the devices, the direction of the transmission, and the coordination of the devices must be resolved during data transfer. This is solved with the processor and the various server circuits on the motherboard. The processor performs the calculations, controlling the data transfer between each unit and the memory. It cannot perform all tasks, but it is not necessary. As long as you transfer control to another server circuit that performs special tasks, you can work with your own tasks. The processor can be expanded with an arithmetic coprocessor, a coprocessor, speeding up calculations with real numbers. Newer processors already include this processor. The clock generator provides a clock signal of a given frequency required for the parallel running and synchronous operation of the processor and the various devices in parallel. The frequency of each hardware device is an integer quotient of this clock, a multiple of that of newer processors using a special multiplier. The base frequency of the very first clock generator was 14.3128 MHz, the latter being much higher. The interrupt controller controls the operation of the interrupts. Interrupts are machine program routines, instruction sequences that perform basic tasks in BIOS. This ROM contains basic interrupts, control card ROMs, and operating systems that are required by hardware devices. These are handled by the processor with higher priority than any program instruction. The interrupt signal is always sent to the processor by a hardware device to draw attention to itself. The interrupt controller receives the interrupt request signals and determines their priority, order of importance, and then sends an interrupt to the processor based on a decision. The processor suspends the currently running programs, starts the interrupt routine associated with the device, and then returns to running the programs. An interrupt can disable disable interrupts with the same or lower priority. The most important interrupts, such as the fault management interrupt, cannot be deleted because it may result in a malfunction of the machine. The DMA, Direct Memory Access Controller, allows direct memory access, meaning that hardware devices can perform their tasks by bypassing the processor, significantly speeding up the operation of the computer. It has its own internal memory of a few bytes in which it can store the data passing through. Multiple DMA controllers can be connected. There are 2 in computers. Direct memory access is primarily used by hard disks. Newer ISA bus motherboards allow hard drives to communicate with the UDMA standard, achieving higher data rates. UDMA 33 is 33 Mbps, UDMA 66 is 66 Mbps, UDMA 100 is 100 Mbps. The programmable peripheral adapter connects each computer peripheral to the bus system. Data sent to or from peripherals reaches the ports through this integrated circuit. Ports, also known as interfaces, are gates that allow input and output devices to be connected to the motherboard so that they become part of the computer. Each port has a 16-bit ID number and address. The processor sends a signal through the control bus and notifies all I/O ports that the data on the address bus is the address of a port. It then sends the port address on the address bus and responds with the corresponding port address. A counter-IC that can be set with a programmable timer program that implements 3 types of accurate delay times. You receive the required sync signals from the clock generator. Its operating frequency is 1.1931 MHz. It keeps track of time, and it also operates the PC's built-in speaker, the speaker. The timer controls the speaker by forcing it to pulsate with a series of pulses, periodic flashes of electrical voltage or current for a given period of time. The denser the pulse strain, the higher its frequency, so the louder the speaker emits. Different mass storage devices and peripherals are operated by different control units through different ports and interrupts. These control units are either directly on the motherboard or connected to the slots in the bus system as separate cards. Motherboards with a built-in, integrated, audio, video, or modem unit, etc. are becoming more widespread. There are fewer and fewer control cards that can be inserted into the EISA slot. For compatibility, so that old control cards can also be used, motherboards also include EISA slots, but they also make motherboards that no longer do. The ATX motherboard is a standardized extended feature version of the standard AT motherboard, which is characterized by the fact that all its structural elements are precisely defined. Peripheral drivers are not connected to the motherboard by separate wires but are directly on the motherboard and can be accessed from the outside. Not only does it have a serial and parallel adapter, but it also has a PS2 keyboard connector, a separate PS2 mouse connector, and an ATX power supply connector. It sends pulse signals to the power supply to turn it on and off, so it is possible to automatically switch the machine to standby mode. If it does not work with the machine, it automatically consumes less power and software shutdown. The ATX motherboard is for an ATX casing. More and more AT motherboards are being made that also have ATX features. Such a motherboard can also be inserted into AT and ATX casing. Each motherboard has several ports that handle peripherals located outside the computer, external input-output. The keyboard is connected to the keyboard connector. There are 2 types depending on the motherboard. AT motherboards have a 5-pin DIN connector, ATX motherboards have a 6-pin PS2 connector. The serial port, serial interface, allows communication with its own controller to RS-232 standard asynchronous serial peripherals, external machines or other computers. The computer usually has 2 connectors, but the BIOS can handle 4 devices, COM1 COM4. During communication, the connected machines may have different clock signals. They only need to operate in one cycle until the transmission of a single character. A character is usually 8 bits, but can be different. It sends the characters bit by bit on one wire at a given rate one after the other and receives the incoming signals on another wire. When transmitting a character, the bits that make up the character are preceded by a start bit that tells the receiving machine that a character is coming, followed by a parity bit after the character if parity checking is applied, and finally a stop bit indicating that the character is over, that is, close the data packet. It generates the time cycle from a 1.8432 MHz clock signal divided by a maximum of 16. Its maximum data rate is 115,200 bits per second, which is the highest rate of 115,200 Hz, 1,843,216. Its connection surface has 9 and 25 poles, respectively. Computers have a 9-pin or 25-pin male pin connector. It is mainly used by modems, mouses and measuring devices. The interference sensitivity of the cable can be low, up to 30 meters. The parallel port, parallel interface, connects Centronic standard parallel-controlled electronic machines to the computer, usually a printer, scanner, and other computer. The BIOS 2 can handle a total of 4 peripherals, LPT1 LPT4. It transmits signals on 8 wires and receives signals on 5 wires, it can send 8 bits or receive 5 bits simultaneously. The connection surface can have 25 or 36 poles. The 25-pin connection cable is more common than the 36-pin cable but is more sensitive to external interference signals, magnetism, so it can be up to 5 meters. The 36-pin connector has a ground wire in addition to each signal wire, so it has much greater interference signal protection. Computers usually have 25-pin, and printers typically have 36-pin, not all pin, mother connectors. The pin connector is received. The standard parallel port, the original Centronics interface, only allowed one-way data transfer but was upgraded to two-way half-duplex, simultaneous one-way mode. Maximum data transfer rate is 150 kbps. The latest motherboards support EP and ECP modes, which are compatible with the standard port. In EP, enhanced parallel port mode, both the transmitter and receiver can control the data transfer rate so that the transfer takes place at the speed corresponding to the slower device. Data transfer rate is 502,000 kbps. The extended capability port, ECP, allows you to use multiple channels, so devices on a multi-device peripheral can communicate with the computer independently of each other on a shared parallel port without occupying the port. The AGP, Accelerated Graphics Port, interface was developed in 1996 to allow increasingly faster video cards to connect to the motherboard on a faster interface without being hampered by the ISA and PCI bus system interfaces, which are already considered slow. It has its own control chip that controls the data transfer between the video card and the main memory, independent of the processor and the bus system. Delivers data over 32 data lines, 32 bits. It only works on motherboards with a clock speed of 66 MHz or higher. Single AGP clock speed 66 MHz, data rate 200 to 300 Mbps, double AGP clock speed 133 MHz, data transfer rate 528 Mbps, four-fold AGP clock speed 266 MHz, data transfer rate 1 Gbps. USB, Universal Serial Bus, is a serial cable bus developed in 1995, version 1.0, and modified in 1998, version 1.1, that connects several different peripherals with their own IDs to the computer at the same time. It operates at a data transfer speed, bandwidth, of up to 5 megabits per second for the first version and 500 megabits per second for the modified version up to a 5-meter cable. Allows you to connect slower devices, such as a mouse, without greatly reducing bus throughput. This is accomplished with low-speed, 1.5 megabits per second, transmission, in which case the cable length can be 3 meters. The peripherals are tree-wired via hubs, a USB device that provides additional USB connections for minimal cabling and maximum data transfer. The USB connector and central hub are included with most AT motherboards and ATX motherboards. For it to work, programs need to handle it. Microsoft's Windows 98 operating system supports USB. Although not yet widespread, more and more USB serial connected peripherals are being made, e.g., modem, mouse, keyboard, stylus, etc. Some notebooks and laptops also include a special port, PCMCIA, Personal Computer Memory Card International Association, developed in 1989. It was originally designed to connect memory modules, but several other small peripherals, such as a network card, modem, etc., or even mass storage can be connected to it. Memory cards are 3.3 mm thick, peripherals are 5 mm thick, and mass storage devices are 10.5 mm thick. It has asynchronous operation, 16-bit data line and 26-bit address line. Its connector has 68 poles. Data transfer rate is 8 to 20 Mbps. There are also PCMCIA cards connected to a standard PC that can be plugged into an ISA or PCI slot or connected to a parallel port. PCMCIA was further developed, and in 1994 a card bus was created that is fully compatible with the PCMCIA bus. PCMCIA cards can also be inserted into a card bus slot that allows 32 Mbps data transfer over a 32-bit data and address line. The clock is 33 MHz. Older motherboards also have a turbocharger sensor, but newer motherboards no longer use this. The point of turbocharging is that, by setting the processor to minimum speed, older programs will also run at normal speed and have lower power consumption. Speed reduction can also be done through software, which is more convenient and accurate. Motherboard structure. I/O ports, control devices, central memory and CPU communication with bus system. 32 and 64-bit cards connect to slots of PCI or VLB bus. 8 and 16-bit cards connect to slots of ISA bus. The PCI or VLB and the ISA bus communicate with bus system. Communication on the bus system. The keyboard, monitor, drivers, printers and I/O peripherals communicate with controllers. The processor and the coprocessor communicate with internal data bus, address bus and control bus. The internal data bus, address bus and control bus, and central memory and peripherals controllers connected to the data bus, address bus and control bus.